The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to the Lighting Controls Podcast. We have another fantastic episode for you today and a returning guest, which is always a fun time for us. So before we jump into everything, let me take a minute to remind everybody that today's episode is presented by the LCA, the Lighting Controls Association.
And it's also financially supported by the National Association of Innovative Lighting Distributors, or NAILD. And also, if you haven't checked out our website, check it out. We've got all of our episodes, a news feed, as well as some merch if you want to support the podcast. But also want to thank our sponsor for this episode, which related to our guest, Toggled. You should check them out, toggled.com, Toggled. They are a fantastic company for IoT application, retrofit, installation for lighting and lighting controls, and they provide a lot of great resources for people using a Bluetooth mesh system for installations for lighting and lighting controls. I think what's really interesting about them is the fact that they have a intelligent fluorescent tube retrofit that has the radio inside of the tube. So you don't need to have anything else. You don't need to go above the ceiling and replace any parts. You just need to pull the tubes out, bypass the ballast, and you've got yourself a Bluetooth mesh system all ready to go. But really great resource, something that actually we have in my day job. Our office is currently using Toggled's equipment, which is really cool. Not that I can show off too much of it, but ultimately it's a really great system. I can't speak highly about it as you know. I think this episode will really help you get a better idea, but ultimately it's a really great resource. Definitely worth checking them out. Toggled, Toggled.com. But now to our guest, Dan Hollenkamp. He's CEO of Toggled and CEO?
COO, Chief Operating Officer.
COO, thank you very much. Dan Hollenkamp, COO of Toggled, and great guest we've had on before. But Dan, other than COO, do you mind just giving us a quick breakdown on who you are and what you do in our industry?
Sure. My name is Dan Hollenkamp. I'm Chief Operating Officer of Toggled. A little bit more than just Chief Operating Officer. I also help with product development, kind of more CTO role, in addition to helping with manufacturing. Electrical engineer by degree. Started in manufacturing and contract manufacturing. Electronics industry, and then transitioned into LED lamp production early on in my career, and have evolved not only with Toggled as a company, but personally, from just producing light sources to building lighting control systems, and now into full building automation and decentralized data in control systems.
Well, thank you so much for joining us again. I mean, it's really great to get you back on the show because, we had a lot of great topics that we discussed last time. And so I'm really excited to see where we go with the conversation today. But, just, from your perspective, as we're seeing things changing in our industry right now, what do you think is something to pay close attention to as it pertains to lighting controls?
Yeah, so I think we're starting to see a little bit of direction of where we're headed. Buildings in general have been the systems in building have been siloed, not only in the actual physical systems, but also in the data that's available. And I think we're starting to see the benefits and actually see it in practice happening, where we're able to break down those barriers and start to see systems work more closely together, and it's becoming more accessible for everyone, right? We've seen buildings with BMS, like sophisticated BMSs, and very expensive controllers that have lots of time spent, lots of money spent making them all work together. Those buildings exist, but they're rare. There's tons and tons of buildings that don't have BMSs. There's tons of buildings that have a thermostat and maybe a few motion sensors, right? And that's kind of the majority. So we're starting to see, adoption and accessibility of systems that provide a lot more than just, on off set temperature. And we're seeing lighting help promote and help push buildings into a more connected world.
Yeah, I mean, I think you're right. I think there's really something about that. There's almost a demand now for the fact that everything was siloed, and now we need to kind of all share the same court, essentially. And so, what are things that lighting controls manufacturers are going to need to pay attention to going forward regarding that? Like, what do they need to really put their investment towards?
Sure. So I think Toggled, we're doing this, but I think it's we need to focus on what data is available, where the data is going, and what potentially could use that data, right? So, in a traditional lighting control system, we might have been thinking of on, off, dim up, dim down, and you have a single device like a switch or perhaps a central controller that's sending out these commands, and the devices just respond. But it that's not necessarily the data you want to have available for other devices. For example, our sensor, we have a battery power sensor with a 10-year battery life that collects temperature, humidity, ambient light, and motion, and in addition, motion density, like how much motion is actually in the room. And we provide that data to the entire network in kind of like standardized units, right? So it's in lumens, it's in counts, it's in Celsius, right? So it's standardized data that anything else can pick up and use however it needs to use that data. We're not limiting it to specific use case because we don't know what the future use cases are going to be, right? We don't know what the future system design is going to be. So I think we need to focus as an industry on making data more uniform, more available to all the devices in the network, whether they're a part of the lighting system or not. And I think we're starting to see some movement in that way. We're starting to see some even Bluetooth. SIG is starting to work on some more standardized models of devices and data formats so that there can be more interoperability in the future. Still not quite there, but we're starting to move in that direction, which is great.
Having all that data from the sensors, being able to see, the amount of sort of people within a space. Are you getting requests from HVAC companies or from potentially even like UVC applications where people want that density data so that they can either affect heating or cooling more quickly or earlier on than they would, or like in a UVC application right? So are you getting requests for that?
Yeah, we are. Being able to provide, what rooms are occupied, when they're occupied, allows you to drive the systems more efficiently, right? We don't need to exchange as much air if we have one person in a room or if there's no one in a room, right? And I think we all see this post-COVID. We don't know what work schedules are anymore, right? It's 1 week, it's like everyone's back to the office, and then the next week there's back, and now we're back to 2 days a week, right? So it fluctuates back and forth, and we end up with buildings that we don't know. There's no way to schedule them anymore, right? So being able to provide what kind of demand is in a room, how are rooms being used now, is really important to providing efficiency, systems that are efficient. Without it, it's always going to be wrong for the occupants, right? And the whole point of these systems is to make a comforting space, a comfortable living space for occupants, right? I always laugh, it's easy to make a building use less energy to shut everything off, right? But it's a terrible place, right? You don't want to be in that building with all the systems off, right? So it's finding that optimization, finding the balance between comfort and energy consumption, resource consumption. And if we have more data, like when spaces are occupied, and then also more granular temperature humidity in every room. It helps you plan ahead, predict what the needs are going to be. You can see the data over time, see how the building reacts to those loads, how many people are in the building, in the future, plan ahead for optimizing the systems.
I think
Yeah,
that
I
makes a
mean,
lot of sense, and it's funny you mentioned that with the scheduling, because I was at a fairly large facility last week, and I was talking to the facilities guys about another project, and I was asking them about occupancy because it's a very large organization, and I asked them what everything's been like post COVID, and that was one of the conversations. Was right now they're in office Tuesday and Thursday. Well, they have to do 2 days a week. And it seems that Tuesday and Thursday are the days most people choose. But it does fluctuate from week to week, especially based on, is there a long weekend? Is it a Friday holiday? Is it a Monday holiday? So they've really gotten away from scheduling all their systems because they were getting complaints of, it's too cold in here on Wednesdays when there's nobody here, or it's too hot on Tuesdays because of this. So it's funny that you mentioned that, because I do think in sort of where we're at currently with populations within offices fluctuating so much, that using that data is a huge benefit to people rather than just relying on schedules like they did in the past.
Yeah, absolutely. In fact, we're pushing all of our customers to abandon scheduling. It seems to be more hassle than it's worth, and it's just like add a few more occupancy sensors to have better coverage, to make sure that if people are only in a specific area, the lights stay on. But yeah, I think scheduling is a feature that's kind of dying. I don't see a whole lot of use for it. Honestly, even for outdoor lighting, for parking lots and signage, like there's better ways to control than a schedule. Whether it's like photo cell, looking at the ambient light outside, or those types of control systems are going to be way better. You're going to be more energy efficient, and the light's going to be where it needs to be. We're really pushing people away from scheduling. It's just not really the right answer anymore. And you can do a lot more interesting things with motion sensors when you're on a networked system, right? So, and this is also where having some decentralized data collection, sharing, and decentralized control lets you do newer, interesting things that save more energy yet make the building look more pleasing to be in. For example, traditional motion sensor might just turn on a single room. Well, if you have a network system that shares data across all rooms with the sensors, you could have, as soon as there's motion in a building or in a hall, you can bring up a basal light level, perhaps across the entire corridor, but then keep an actual usable light level where the occupants actually are. So that way the building doesn't look completely empty and dark. There's still some light in the building when you look down the hall, or maybe look into another room. You don't feel like you can't see anything in the building, but yet you're still optimizing the amount of energy that you're saving, right? So in networked controls, decentralized controls allows you to have more sophisticated control schemes like that than just on off based on a single zone or single room.
Now I feel several specifiers, especially engineers, prodding me right now and going, hang on a second. Are you saying scheduling is not an option anymore? And I mean, I agree with what you're saying, Dan. But I definitely know there are a number of people out there who will not let go of scheduling, no matter how convincing the argument is. But I'm curious, what you have to say to people who are basically like, scheduling has worked for so many years for me. It's reliable, doesn't require line of sight for detection. Like there's a number of Luddite perspectives, I guess, when it comes to keeping that scheduling. And so I'm curious if you have any thoughts on that matter.
I think we'll always offer scheduling. In fact, we offer some pretty interesting, sophisticated scheduling where we offer cloud scheduling, edge scheduling, and then down to node scheduling. So like we have all sorts of layers of how deep the scheduling is, and how we always try to keep things as close to the actual use as possible. But it requires maintenance, right?
Yeah.
Like schedules require maintenance, and if you're not maintaining it, you're wasting energy, or you're making your tenants or your occupants upset. So
Right.
scheduling's there. If you want to manage it, I think it comes down to it's management, right? Someone
Right.
has to be managing the schedule, and it's
Absolutely.
work, and it's going to be wrong at some point. So, there's better ways of doing it. That's I mean,
But
I
yeah,
won't
so I mean,
force I won't force you to do it, but I
it's
think
a
people will
fixed
start to
way of
realize.
looking at something.
Yeah.
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 So yeah, it's a fixed way of looking at things. It really kind of sticks people into a form factor that is very rigid. Whereas if you create more dynamic scenarios, such as what you were talking about, where all circulation in a building comes up to a certain level when there's a level of occupancy in the building, but the task illumination for that person is always going to be at their needed level, whereas it's just sort of like a ghost presence of illumination rather than really anything of impact. And similarly to exterior lighting, it can also be done that way. We've seen case studies where traffic patterns have been followed and preempted with illumination, essentially.
Sure. Yeah. And there's, I guess there's an in between also, right? So, even if you're not fully utilizing a fully automated control system where it's hands off, and we let the system learn, how the building's being used, right? And so it gets interesting because in the future, motion control won't necessarily be what we know it, where it's just I see motion, the light turns on, even in a room, right? It's going to be I see motion. There's context of what day it is, what's happening on that day, what calendars are loaded for events, and have it have on profiles or default settings based on what the system thinks is appropriate for that time, and it can learn over time, right? So those things will be coming, and that's kind of like the fully automated. I hate to use AI, but some sort of machine learning that allows you to have the building adapt to your needs. Much like there's some thermostats out there today where if you change the temperature, it learns what you've changed, and applies your input to future settings. So I think lighting systems and other control systems in buildings will start to adapt to that kind of control. Before you get there, for people who are still want to have a rigid schedule, we can always provide data, right? So the data is there. You can have an air gapped where here's the data. This is what it's suggesting should be set in the schedule, and then we can manually apply it for people who want to have a little bit more control.
Right.
But honestly, in my experience, people want to have control. Most people don't want to actually control it, right? So they want to have the power. They want to be able to control what they want. But when it comes to actually doing it, it's like after a while, it becomes tedious, and no one wants to do it any longer, right? So that's when let the system just run its course.
Well, I think that goes back to several conversations we've had with various people recently about the automation of lighting and the idea of it being a simple control system with a complex back end to really manage everything. So you walk into the space, it executes what you want it to execute. You don't have to fine tune it every single time. So, residential seems to be much further ahead on that, because we have these like Alexa, turn the lights on kind of mentalities, and that is sort of has machine learning in it, so it learns those settings that you prefer. We don't really utilize that in commercial applications as much, and so I'm curious What, if any, roadblocks we have going on there?
Yeah, so there's so I would say yes. Consumer lighting is ahead there, but I feel like commercial lighting is also leading the way in robustness, and probably interoperability. Um, you know, I've owned multiple, consumer lighting control systems in my home, and they all get abandoned at some point, right? I've had conversations with friends and people who are not in the lighting industry, and they have very much similar experiences where they buy something that's great in the beginning, and then all of a sudden lights drop off the network, switches don't work anymore, and it basically gets ripped out or abandoned, just because it doesn't have the robustness that's really required for it to become an actual utility within the building and not just a novelty. So I think this is where network lighting controls and building controls are strong at having a robust system. But now we need to take the conveniences and some of the nice novelties from the consumer systems and move them into the commercial world. But it takes
Right.
there's a lot more at stake than in someone's home, right? There's a lot more people involved. There's a lot more financial impact. The building itself is worth a lot more money, right, than most people's homes. So we have to have a little bit of caution just to make sure that the systems are robust enough, so that the outcome is acceptable. We also don't want to scare people off too much from some more advanced systems before we get enough adoption, right? Because there's so much benefit to it, but it is new for a lot of people.
Yeah, and I love the idea of being able to do, take what I do at home into the office. As an integrator, I don't want to deal with it. Like I do, but I don't, right? Because can you imagine programming 50 offices on a single floor and then having to go 18 more floors and do them all and talk to every user, which is never going to happen, right? About what their levels are and what their wants are, or you give them a blanket controller that they somehow program to their own device and they set their settings for that space. But then now you've got to teach maintenance how to reset it when employees move locations or are let go or leave or this or that, or new hires come in. And it just, as much as I want it to happen, I also at the current moment think it's a logistical nightmare.
Yeah. And I think this is relative to the scheduling conversation, right? Where in the have a scheduler mindset, it is a lot of work, right? If once we have systems that learn themselves, right, provide setting updates based on user preference and usage, it's now no longer work for the integrator, right? It's no longer work for the building staff. They need to maintain the system, make sure that the right products were installed, but they're not now stuck configuring everything constantly, right? So it's going to get better.
So now,
yet, but it's going to get better.
am I hearing that you're teasing the idea of machine learning in Toggled's infrastructure?
We are working on that. So right now we have solid control, solid data collection. We're rolling out a new data platform right now, with help of our parent company Altair Engineering. They have a new IoT platform that we're utilizing in addition to their vast machine learning and data analytics heritage. So that's now the next step to come full circle, right? So we have really good control. We have decentralized control, in the devices. Really great data collection. So now we're going to close the gap and do data processing, and then finally feed it back into the system and close the loop. So that we're working on right now. Not there yet, but we're getting close.
Well, and just so that our listeners have an understanding, I mean, some probably aren't familiar with the term machine learning or even really what artificial intelligence or AI refers to. And so I was curious if you wouldn't mind just giving a quick um, reference or description of what that is.
Sure. In our case, it's really just collecting enough data that we can start to see patterns, right? So it's collecting lots of data about how a device is used, when a device is used, all the context around it, and then really just starting to look for patterns, right? So
Mm.
at first it all looks like noise, but then you can start to see like the same thing happens at the same time every day. Someone walks into the room, the lights turn on, but they immediately adjust them, right? And if you see that
Mhm.
pattern, when you're processing the data, you see that pattern again and again and again. We know we can just adjust the lights at this time when someone walks in the room. That should be the default setting, right? We shouldn't wait for the user to adjust it. So I mean that's kind of machine learning at in its essence is just looking for a pattern of something that happens again and again, and skipping a step, right? Like let's just go right to the end result we know we're going to get to anyways. So
Right. So if somebody walks into a room and it's set to 72 and they adjust it to 68 every single day, the machine learning would then go, okay, we're not going to go to 72 anymore in this room. We're going to go to 68 because this
right,
person keeps changing it. So
right.
yeah, I think, as far as lighting controls go, that's a step that could be a major game changer because of the way people currently look at lighting is, either too complex or not complex enough, and at the same time hard to get what you want. And
Mhm.
so if you have this machine learning added to it, you might help at least a portion of those people who have those complaints. And I think in combination with the other things that you're talking about, it really does kind of help us get that much closer to an idealistic way of doing lighting controls for, non-industry people. I think industry people, we all understand, at least to a degree, the jargon that we throw around, and we understand to a degree how lighting controls work. But anybody outside of our industry, it's almost an impenetrable thing. So having the intelligence working for those people of those spaces, I think it makes a lot of sense. But
Yeah. Yep.
so,
Absolutely.
and then there's another term you used here, and I just want to make sure that our listeners are following this because I think this word is growing in popularity in our industry, but isn't quite at a ubiquitous level, which is decentralized.
Yeah.
Do you mind explaining what that is?
Sure. So decentralized is probably one of the most important parts, especially of toggled system, but probably where we need to be going is not having a central controller anywhere. Right. There shouldn't be a
Mm-hmm.
central controller anywhere in the system that can fail, because if it does, we're in trouble. Right. So decentralized is really having each device be responsible for itself, right? Being able to make decisions
Mm-hmm.
based on data that it sees. So, for example, we have a room of 50 tubes, right? 50 toggled IQ enabled tubes, um, and a handful of motion sensors, right? The motion sensors tell the network, I see motion. We let the tubes decide whether they should turn on or off or what level they should go to, right? And the reason we do that is because if something fails anywhere, if one sensor fails or if a tube fails or a switch fails, every other device in the system keeps operating as it should, right? So it provides a lot of redundancy, but it also provides a lot of unique control methods of control, or you can do things you probably couldn't do before. For example, you could, let's just say we have a parking garage, and we have fixtures with motion sensors built into them. As you approach one of them, we can have that light turn on to the specified light level, the design light level, but we could have every fixture around it turn on to 20%, 30%. come up a little bit in level so that you can see beyond just, the one light fixture that you're under, right? So when you're driving or walking, you're always trying to look ahead. You're not always looking just right where you are. So being able to provide some illumination in front of you is a huge benefit, right? So in a decentralized control lets you do that without having to write every scenario into a controller somewhere, right? So you could also have, lights turn off in a certain sequence, for that tube example where we have all the tubes in the room. With a decentralized control system, we could have every single lamp in that room have a different vacancy timeout, right? So you could literally have them seconds apart and watch all the lights turn off in sequence from a single motion command, right? So there's just so much more that can be done, so much more granular control that's possible with the decentralized system. And we don't have all the risk of a single controller somewhere, that's running these complicated lighting schemes that can fail. And then we end up in a situation where lights are stuck on, lights are stuck off, and those things just can't happen, right? Like we have to have a super robust system where every device can keep working to its best of its ability, even when things around it might be failing. Because ultimately things will fail, whether they're because they're physically damaged, or things do break,
unexpected,
right? So
unexpected corruption
exactly. So we just have
to
make sure things keep working.
No, it's really fascinating, and I want to kind of package this a little bit because it's really an interesting and nuanced difference between decentralized versus centralized. I mean, in a centralized lighting control system, you have a processor in the middle basically acting as a director saying, you go to this, you go to that, you go to this. In your system, it's not that there's a director giving commands. It's just that every device is giving out information in a different way. So an occupancy sensor is just going to say, hey, I'm detecting motion. Anybody who can hear me, go to whatever setting it is that you're supposed to under these conditions. And so it's just about sharing that data. It's not about, giving the instruction. And so to your point, with that capability, with a way of managing that data and collecting that data, you have the added layer of each unique entity having its own response criteria to that information.
Exactly. And then the devices can decide to do whatever they want, whatever they've been programmed to do, right? So a lot of cases it might be ignore that there's motion, right? And that for us, it also helps if making sure that the right thing makes it on site, right? Because the motion sensor just sends out the occupancy information. We can't ever specify the wrong sensor, right? Because everything can be set to vacancy or it can be set to occupancy. Both.
Well, and that's the nice thing about your sensor as well, which, this is starting to infringe on an advertisement, but, it's an all-in-one sensor, which detects not just motion, but it detects daylight, humidity, temperature, all of that. It's just the single sensor that you have. So no matter what, you are collecting that data wherever you are with that sensor. So later on, if at some point you want to take that data of whether maybe you're not connected to the HVAC system yet in that space, but you are detecting fluctuations of temperature, you can already start incorporating machine learning in that space. And then if you connect to the HVAC, you can be able to integrate and streamline that process a lot faster.
Absolutely. That way you're never have the wrong equipment on site. You can keep adding features, adding functionality. A lot of times it might just be a software adjustment, right? Changing the way some parameters. Or if you add extra hardware, we didn't specify the wrong device somewhere else. We can't have that feature now because we got the wrong sensor or this or that, right? So and that's we're providing just the data outward from each device, and letting any device collect that data that may have a use for it. We don't want to control who uses the data either. If you're on the secured building network, that data is fair game for any device in the building, right? Because there may be a use case that we can't even think of right now that is super beneficial. If this device on this side of the building can get data from a sensor on this side of the building, we may save tons of energy or make the building operate 10 times better, but we can't see that use case at this moment, right? So we don't want to limit those future use cases by not sharing that data.
Well, and I think that addresses a term that I keep hearing, and I'll use it every now and then myself, which is future proofing. And I think a number of people ask, how do you future proof? And I think that right there is you said something that I think really sticks to that, which is we can't predict what's gonna be necessary, but if you're flexible enough, you can be able to adapt to future scenarios that might be unpredictable. And so when it comes to future proofing, it's not so much let's implement everything we can under the sun. It's more of let's be open to the implementation of anything that pops up. And that's another really nice thing. And so, when it comes to that, what does that process look like for Toggled? If say, for instance, you already have something installed and programmed and done, and the occupants are happy, but then they go, oh, what if we did this? What does that look like?
So in most cases, for us, it's you add the device that provides the functionality you need, and it works well with everything else, right? Because we're using standardized data formats and sharing it across the network. So the infrastructure topology already supports kind of this future use, because we're not limiting who sees data or using some kind of just the motion sensor only sends on or off, which isn't usable for other devices particularly. But then, right, we also have firmware updates and things like that where we can continue to help prevent things that might be left behind. Keep upgrading them to newer functionality as new codes or requirements pop up. But really, it's just having that open data collection, open data sharing that allows future use cases that we haven't seen, right? So we just by providing all that data, as a new device shows up that we couldn't think of, it has all that data that's also
right. And so basically your responsibility is showing how to access that data to that third-party manufacturer that's trying to tap into it.
Yep, absolutely. Yeah, we like to share. It's not ideal to have translation anywhere. It's still very much a reality, and it's going to be for a long time. But we also provide all the data that we have on our native Bluetooth network. We also will translate and put onto other networks bidirectionally. So BACNet's a big one for us. All the data that we have, we can push all of that data to BACnet, and if there's any data on BACnet that's relevant, we can also pull onto this network. Same thing for other protocols, whether it's we use a lot of MQTT or even other protocols like LoRaWAN and or just open API calls. Sure. Really, we're just trying to spread data wherever it needs to be, trying to make sure it gets there, and not limiting what data can make it to which platform or which network. So ideally, go ahead.
Yeah, I think that flies in the face of arguments that we've heard. We just had a manufacturer on a little while ago talking about, we can't get to a non-proprietary point right now because everybody's playing that game. But you guys aren't playing that game. You guys, Toggled is right now essentially using a non-proprietary communication standard. And as a result, the argument could be made that somebody could come in and say, well, use our sensor instead because it can communicate the same channels. But I would say that the argument works both ways, and it's kind of a double-edged sword to be on a proprietary system, because you can't tap into a toggled system that if you have a proprietary protocol. And so nobody's going to be able to come in and sub out your equipment or parts of the systems, because nobody currently uses those open standards.
Yeah. So that is one big challenge that our industry still needs to overcome is the interoperability. And a lot of it comes down to who's responsible for the system, right? It's the integrator, right? They're the one who's going to get the nasty phone calls from the customer when things don't work together. But I'm not sure who the integrator calls then, right? Who the installer calls, right? When company X and company Y's devices aren't working together, both are going to point fingers at each other, right?
Well,
that's
and
just
so
the reality.
that's a good question for Ron. I mean, Ron, you do this on a daily basis, because especially with DMX, you rarely have, complete systems by one manufacturer. So what do you do in that situation?
That's where it really comes down to, like, DMX being a very rigid standard. There are a lot of test utilities out there. So it's very easy for me to eliminate control source A and put my own control source in path and say, okay, this works or it doesn't. And if it doesn't, I know it's control device B. And if it does work, it's like, okay, now I need to look at the data coming from device A. Is it too fast? Is it too slow? Is there a break somewhere there shouldn't be? What is the issue? So having the test tools then allows me to go back to the appropriate manufacturer. Because you're right. Otherwise, without testing, I can call both manufacturers. They're going to go, well, without more information, I don't really know, right? So you have to be able to test both directions and be able to isolate where you're hitting that stumbling block.
Yeah. And DMX is probably a little bit easier just because there's very defined messaging and timing, right? It's very, very well defined. And it's pretty standard values that are passing through, right? A channel can only be, this range of values.
And also it's a central versus a decentralized. DMX by default must be a central control system. And so as a result, it completely flies in the face of what Toggle's trying to do to focus on a DMX format. But I think to Ron's point here, having the ability to test and ensure that the two-way communication, you can identify where the breakdown is. And I think, what's really interesting is the fact that you're basically just sending the data out. So, so long as that data is picked up and doesn't get corrupted along the way, it should be the other party's responsibility to make sure that the programming works.
Right. Yeah, absolutely. Yeah. And in our case, that's where we think decentralized is really key, because if a device isn't operating the way it should, it's that device, right? You can see what data is coming in, what data is available on the network, and if it's not doing what it's supposed to, it's clearly it's that device, right? So I think things will get better. It is just a little bit more challenging. I think DMX is fairly directional. The data pretty much comes from a controller to an Apple device. And we tried to have bidirectional communication, and it really never took off, right? Because of challenges, right? I think that was actually part of the problem with DMX. We couldn't really get close to a standardized return message format and with all the different manufacturers and everything, right? So similar challenges, but I think we'll probably get there with either Bluetooth or some sort of network lighting controls, network building controls. And I think that's, you got to start thinking a little bit outside of lighting too. I think it's really going to become network building controls and not necessarily just network lighting controls.
No, I think that's a really good point. And so we're almost out of time here, and I just want to package up what we've talked about. Really fascinating stuff, though. I think ultimately really expands upon what we discussed in the previous episode that you were on. And anybody listening should definitely check out that episode if they haven't listened to it yet. But really, I mean, when we're looking at a toggled system, we're looking at a IoT platform that's basically collecting all of this data, and on top of that, Toggled is managing the data, which is not like 100% consistency within our industry, that the company that is in charge of the equipment is going to be in charge of the data. But at the same time, whereas other manufacturers might try to gate what data they're collecting or limit what data they're storing, Toggle is just basically trying to grab all data, store it for later use, whether or not it's actually going to be useful. But because of that, you have the ability to leverage that data in ways that create more unique application designs for lighting controls, where you have conditional logic, where it's an if-then criteria that can really adapt to the needs of the occupants, as opposed to being a rigid time schedule, which is a more traditional lighting control scheme. But on top of that, it sounds like, the goal is to get to machine learning, where you can really have predictive models and adaptive models to the occupant's needs. And so if somebody keeps going into a space and changing something, eventually the system will go, okay, let's just do that for that occupant. The occupant doesn't need to do that anymore. And ultimately, I'd be very curious to see when that comes out, how that works and what the logic framework is. It sounds like you're going through a lot of heavy testing right now anyways. So, I think machine learning as a whole, outside of our industry or inside of our industry, is still fairly new and needs a lot of testing and reworking. But ultimately, that's really the element here, is getting that data, but then sharing that data. It's not just enough to collect and store, but then how do you disseminate that data? Because, lighting controls for a very long time has been incredibly siloed. And I think part of that is the inability to integrate in an easy format. And so instead of just kind of hoarding all that data and hiding it behind a wall of a different protocol or proprietary system, you're just saying, okay, here's the data. If you need this data, here it is. Anybody listening on this network can pick it up. And we talked previously about cybersecurity. So anybody who's poking me right now going, hey, that sounds like a really insecure system, take a listen to our previous podcast episode where we talk about that. But ultimately, having that huge amount of sharing is integral to that next step of what you're talking about, which is getting to building management systems and no longer just going lighting controls, HVAC, security, etc. You're just looking at it as a building.
Yeah, absolutely. And not only breaking down the silos, but also being able to provide this level of control, to all types of buildings, right? Being able to pick up the 1,000 square foot, 1,500 square foot retail building, or small businesses, mid-sized businesses who don't have BMSs, right? So not only providing that intelligence, also providing it to everyone, and that's really where we're pushing.
Sure. Well, Dan,
it's so fascinating to see where everything's going. It really is. Yeah. Just like decentralized versus centralized, and that whole argument. And then, but it is fascinating to listen to you talk about decentralized and how you guys are implementing that, and the advantages of having a decentralized system. And there is just so much to unpack there. So anyone who missed out on the first episode, make sure they go back and check that out and use this as a follow-up. But yeah, Dan, thanks so much, man. There's everything from AI and machine learning to decentralized controls. There were probably some bears or lions in there somewhere. It's just everything and oh my, right? There's just so much going on. And I love it. So Dan, thank you so much for coming on again, man. We really appreciate you taking the time to come on and chat with us.
Thanks. Appreciate
So
you guys having me.
yeah, man. And just, I'll take this moment to just remind everyone that today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. And thank you so much to Toggled, who is our sponsor for this episode, as well as our guest for this episode. Really great system. If you haven't been listening to this episode, then you've missed a great opportunity for learning more about the Toggled system. But if you were listening, we talked about some really great stuff, and adding on top of what we talked about, API integration with a lot of systems can come at a premium, whereas with Toggled, it's covered in the cost of the system already. If you want to integrate with other things, and as we discussed, there's reasons why it's a low cost situation with Toggled, but ultimately the support is there. They will help you integrate with whatever you need to integrate with, and no added premium for that, which is really a fantastic resource. I can't recommend them enough. Check them out, Toggled, TOGGLED.com. Thank you so much for joining us here today. And Dan, thank you again. This was a great conversation.